How we doing, ladies and gentlemen? We are going to dive into chapter 2.4, which is library of functions and piecewise functions. And that's our goals today. We're going to graph these functions listed in the library of functions, which you can always find in your calculator. And last but not least, those piecewise functions. Okay, those we're going to have to do by hand. And let's start taking a look at the different type of functions. We call these the library of functions. Okay. So these are all going to pass the vertical line test. If we take a look, they have a linear function. So you might see, again, f of x equals or y equals. So I'm going to go ahead and write these in function notation. So you might see like f of x equals mx plus b, something like that. Or f of x equals, I'm just making this up, 2x plus 5. So remember, we put our pencil on the b. So we go up 5, 1, 2, 3, 4, 5. It's not hard, you see, man, we're having fun now. It's time for rise or run, and we go, we will graph you. We will graph you. Brought it back from chapter 1.4, so we're graphing lines, so I go up 2, 1, 2 over 1. Up 1, 2 over 1. And again, nice, pretty straight line. If you have a straight edge, it works great. I've got a nice, pretty ruler right here. IDs. If you got an ID, looks great if you're doing this by hand. I always do arrows on the ends of your graphs, so it looks nice and pretty here. Okay. Function, if it's a constant function, so the next one, you're going to get f of x or y equals a number. So for example, you might see like f of x equals 3. Okay, so we need to know that's straight across, so we're going to count up 1, 2, 3, and we got to know that's a horizontal line, just going across. So if it's a y equals horizontal, we got y equals 3 or f of x equals 3. Okay, now just for fun, even or odd, this is symmetric to the y-axis. We know this is an even function. A little review, getting you guys ready for the test. The next one I have is f of x equals x or y equals x. That's called the identity function. So in this case, my b value is 0 and my slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1 from the origin. Okay, so the identity function basically goes straight across the origin. And it looks like that. So that's y1 equals x, or in this case, f of x equals x. And even or odd, this one is symmetric to the origin. So this is an odd function. So far, so good. So we're working our way through the library of functions. That's our linear one. So now we start changing. And the next one we got is the square function. So I have f of x equals x squared. And you probably know what this is. It's a parabola. So 0, 0, 1, 1, and then over 2, up 1, 2, 3, 4. And it is symmetric to the y-axis. So you have negative 1, 1 and negative 2, 4. This is an even function. One of the most famous even functions that are around. So again, this is even, symmetric to the y-axis. Next one we have is the cubic function. So that's f of x equals x to the third. So if I plug in 0, I get 0. If I plug in 1, 1 cubed is 1. If I plug in 2, 2 cubed is 8. So I go 2 comma 8 right there. And if I plug in negative 1, negative 1 cubed is negative 1. If I do negative 2 is 8. Negative. And this is a little S curve we talked about. Looks like that. Okay, and that one is definitely symmetric to the origin, so that is an odd function as well. Okay. The next one we have is the square root function. The square root function looks like this. I've got f of x equals the square root of x. So again, remember, you can't have square roots that are negative, so there's nothing on the left side of the y-axis. But you can do 0, the square root of 0 is 0. I can plug in 1, the square root of 1 is 1, so 1, 1. And I can do 4. The square root of 4 is 1, 2, 3, 4, up 2, 1, 2. Okay, I can even do 9. The square root of 9 is 3, so over 9, up 3. And basically what this is a parabola, half of a parabola on its side. Okay, and this one is neither odd or even, so it would be a neither. Okay, so there's our square root function. And then working our way down, if you're working on my notes, okay, I got 3 more for you. The next one I got is the reciprocal function. So reciprocal means flippy flip, take 1 over x and flip it. And if we talk about domain, we can't have x to be 0, and the reason is there's an asymptote there. Or the reason why there's an asymptote is because x can't be 0. Okay? You'll also never get y to be 0, so there's actually a horizontal asymptote here as well. So I'm going to draw in just dashed lines for my asymptotes. Okay? Now if I plug in 1 divided by 1 is 1, so you have the corner point 1, 1 on here. And what happens is it's getting closer to these asymptotes, it's just never going to touch or cross them. So it kind of looks like this. Okay, and it is rounded here. Okay, it's not boxed out, it is slightly rounded. If I plug in -1 for x, 1 over -1 is -1, so that's going to be right here, -1, -1. And your graph is getting closer and closer to these asymptotes, but they never touch, and it's rounded out. Okay, so it looks something like that. And this is also symmetric to the origin, and it's an odd function. Okay. Absolute value function we've seen in our calculators. Again, this is in the math menu. Over to number, we have absolute value of x. I've shown you that one before. That's that cheerleader function. 0, 0, 1, 1, 2, 2, 3, 3. And -1, 1, -2, 2, -3, 3. Looks something like this. We call this the cheerleader because it looks like a V. V for victory. This is an even function. Okay. All right, so the last library function, and we don't spend a whole lot of time with this with regular pre-calc, it's called the greatest integer function. And the best way I can explain what the greatest integer function is it basically rounds down. So no matter what, it always rounds down to the nearest integer. Okay, so if you can remember it rounds down, we're good. Okay, so what does that look like? So f of x equals the greatest integer function of x is what you're going to see. Okay, so where do I find that in the calculator? It's always helpful to kind of see that. Let me zoom in a touch so you can see. Okay, if you go to the math menu, go over to number and toggle down or press number 5. It's number 5, the greatest integer, int. Okay, so if I plug in 0, I get 0. So 0, 0 is part of the graph. If I do the same thing, math menu, number, int, if I do like 0.1, it rounds down to 0.1, rounds down to 0. Okay, if I do it again, math menu, number, integer, if I do 0.99999, it rounds down to the greatest integer that is less than that number. So the greatest integer of 0.999 that is less than that is 0. It always rounds down. And then if I go to the next one, if I go to 1, the answer is 1. So what that looks like is it goes straight across, but then at 1, it's an open dot. And then it hops back up to 1, 1. And now that's a solid dot. And it goes straight across, and it hops up. It's open dot. Hops up to 2, 2. Goes straight across, open dot, hops up to 3, 3. And it looks like that. Okay? So it just follows that pattern. And I'll show you what it looks like in the calculator. If I have y1, I go to the math menu, I go over to number, and I go to number 5, and then type in x, x is next to alpha, and I graph that. I'm in zoom 6, zoom standard, and this gives you basically the staircase of the greatest integer function. Okay, this is another great way for you to plug in some numbers. If I go second trace value, I can plug in some numbers. If I want to plug in 0, I get 0. If I want to plug in 1.9999, it rounds back to 1, so it stays down there. Okay, it always rounds down. Let's move on to goal number 2, which is piecewise functions. Okay, basically what a piecewise function is we're piecing together the graph to make one graph. Okay, that's the idea. So we remember, if I have the absolute value of x, we know that's the cheerleader one. Looks like this when we're all done. Okay, well, we can look at this graph as a piecewise. So this is how I do it. And some teachers teach it different, but this is how I do it. So I've got f of x equals or y equals x. So I'm going to graph that. Okay, I'm going to graph this part in blue. So we know that this is the identity function. We're going to start at 0, 0. Okay, for my b value, and then my slope is up 1 over 1, up 1 over 1. Looks like this. So it looks like that, and I make a dotted line. That helps me visualize it. Okay. Now I don't want to graph the whole thing. I want to graph it over this inequality. So I want to graph it where x is greater than or equal to 0. So I think of a number line. So here's 0. I'd say parenthesis or bracket left or right. Well, in this case, I'm going to do solid dot because it's equal to. So instead of bracket, I'm going to do a solid dot, and it's shaded to the right. So my shading would be going this way. So I go to my graph. I find 0. Here's 0. It's at 0, 0. I make a solid dot, and I shade to the right. Now, I don't do squigglies. I just connect the dots. That's my shading to the right. So my graph starts at 0 and goes to the right. This other part, if you want to erase, you can, but I just leave it like that. I know it's not part of my graph. Okay? Because I want to do the next side. So the next side, I've got f of x equals, or in our case, y equals negative x. So I know my b value is 0. And then we have our slope, that's negative 1. All right, so again, my b value is 0. My m is negative 1. Remember, that's negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. You can also go up and to the right, up and to the right, up and to the right. Okay? Now remember, this is called a piecewise function. It's a piecewise function. So when I connect the dots, it should pass the vertical line test. So I know I'm not going to connect these dots because it wouldn't be a function. Okay? And if I look, I want to graph where x is less than 0. X is less than 0 right here. That's a parenthesis, or in this case, I'm going to do an open dot. And I'm going to shade to the left because it's less than. So I go to 0, 0. Here's 0. There's my open dot. And now I'm going to shade to the left. Okay, so I connect the dots towards the left. Okay. Now the question I always get here is what happens when you have an open dot and a closed dot and they share the same spot? Well, if I have an open dot, you can see me here, but then I put a closed dot, well, now it looks closed. Okay, so this open and closed dot share the same spot. This is a closed graph. Okay. All right, so that's the idea. We're putting these two pieces together. Sometimes you have multiple pieces. Okay, so that's how I graph it. So let's take a look at the next one. Okay, the next one I have is I have a piecewise. I have f of x equals negative x, and it's between negative 2 is less than or equal to x, which is less than 0. And the other part I have is f of x equals x squared, where x is greater than or equal to 0. Okay, so again, I always look at these individually. So the first thing I got to be able to do is graph y equals negative x. All right, my b value, we know is 0. It's a line. And then my slope is down 1 over 1, down 1 over 1. All right, down 1 over 1. So I'm going to make a nice, pretty graph here. Following my slope, down 1 over 1. Up and to the left, up and to the left. Looks like that. Okay. Now I don't want to graph the whole thing. I want to graph this inequality. I want to graph between negative 2 and 0. Okay. Well, at negative 2, it's equal to, so that's going to be a solid dot. And at 0, it's not equal to, so that's an open dot. And this is an and are shaded in between. So I'm going to go to my graph. Okay, I find 1, 2, negative, and I go to that dot. So this dot is at negative 2, 2, right here, at negative 2, 2. That's going to be a solid dot. Okay, then I go to 0. So in this case, on this line, I'm at 0, 0, and now I make an open dot. And I shade in between. In this case, I connect the dots in between. I make a little bar there. Okay, so instead of making this all squiggly, I just connect the dots. That's how I do my shading for those. Okay, so I do the next one. So that one's done. That was easy, hopefully. I look at this one, I've got y equals x squared. We probably know that this is a parabola. Okay, so graph your parabola. So I'm going to go 0, 0, plug in 1, that's 1, plug in 2, 2 squared is 4. So I'm going to go over 2, up 4. 1, 2, 3, over 2, 3, 4. Okay, and you also got negative 2, 4, negative 1, 1. Okay, so my parabola looks something like this. Okay, now I don't want to graph the whole thing. I want to graph it over this inequality. I want to graph where x is greater than or equal to 0. So on a number line here, 0, equal to means it's solid, greater than says I would shade to the right. Okay? So I look at my red graph now, my red parabola. Okay, I go to 0, in this case 0, 0 is right here. It says to make it a solid dot, so I make that a solid dot, so I fill in that open dot. And then I graph to the right. So I follow my graph and connect all the dots to the right. Okay, so this graph starts here. It's a straight bar. It's a solid dot. And then I have a parabola on the right-hand side. Okay, and there's my graph. All right, I got a couple more for you. Okay, again, I should be able to take questions on Monday when I'm back. All right, last one. Now I got 3 pieces. Oh my gosh. It's not a big deal. You can do it. So the first one I got is y equals the absolute value of x. Okay, remember that's the cheerleader one. We just did that earlier. So we got 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, dot, 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 dot. Negative 1, 1, negative 2, 2, negative 3, 3, and so on. Well, we don't want to graph the whole thing. I would connect all the dots. I want to graph just a part or a piece of it. That's why it's called a piecewise function. So I want to graph that one over negative 3 to 0. So here's negative 3 and here's 0. Okay? Equal to negative 3, so it's a solid dot, and not equal to 0, it's an open dot. And then I'd shade between. Okay? Same idea. I go to negative 3, so I count over. 1, 2, 3, and I go up to 3. That's a solid dot. So negative 3, 3, solid dot. Then I go to 0. In this case, 0, 0, open dot. And I shade in between or connect the dots in between. Now, again, I say shade, but that's the idea. Okay? I just mean connect the dots. I'm not graphing the whole thing. I'm just graphing a piece of it. Okay? I'm going to do this last one second. So the next one I got is y equals x cubed. Remember, that's that S curve. Okay, staying alive, staying alive, staying alive curve. So I graph it, and I got 0, 0. If I plug in 1, 1 cubed is 1. If I plug in 2, 2 cubed is all the way up to 8. And you can do the negatives, negative 1, negative 1. If I plug in negative 2, I get negative 8. Again, this is an odd function. But I don't want to graph the whole thing. I want to graph where x is greater than 0. So in this one, here's 0. That would be an open dot, and then greater than is shaded to the right. So I go to 0. That's, again, 0, 0 is an open dot. And then I connect my S curve to the right. The other part of the curve is not shaded or connected, so it's not part of my actual piecewise. Okay. The last one I got for you is I got y equals 1. and that's when x equals 0. Okay? Now, if this was over lots of x's, if that was an inequality line, or an equality sign, I would have a straight line going across. That'd be over lots of x's. But this one is over just one x. Okay? And basically what that is a coordinate point at 0, 1. This is just a solid dot. So if I looked at that right here at x equals 0, I would just have a solid dot on 0. So at 0, 1, right there is a solid dot at 0, 1. Okay? And that's it. All right, questions. I wish I could take them, but I can't. One of the questions you guys might see is like something like this. They might say, hey, what is f of -2? They might ask you a question like that. Well, if they ask you what's f of -2, you have to know where to plug it in at. Okay, so I have an x value of -2. I have to know, is that in this inequality, this one, or this one? Well, -2 is not greater than 0. -2 is not equal to 0. -2 falls in this category. So then I would plug that in right there. Okay, so I would do the absolute value of -2, and we know that's 2. That would be my answer. So these tell me where to plug in this value. Okay, so you could see some algebra related to that. Okay. All right, ladies and gentlemen, last but not least, what do you do if they give you the graph? So now we got to be able to do the converse, which is just going backwards. Okay, so now we see a graph of a piecewise function. We got to come up with the definition. We got to come up with the pieces of it. Okay, so we have f of x equals, and then there is two functions here, two pieces, and let me zoom out a little bit. So we have two pieces, and then we have two inequality signs. So we will pause right there. All right, ladies and gentlemen, so the last thing we have to do is it says we got a graph. The graph of a piecewise defined function is given. Now we have to come up with the definition of each one. So the idea is I have 1, 2. I have two functions here, and I have two inequalities that I need to come up with. I have two constraints, okay? So we're going to look at each one of these individually. I'll work with the top one first. It doesn't matter which one you do first. We clearly know this is a line. We know this is like y equals mx plus b. So we need to come up with those two things. We need our b, where it crosses the y-axis, put a little hump down there. And then we're looking for our slope. We're looking for m. So I take a look. My b value is right here at 0. Okay, so I know b is 0. And then I got to figure out my slope. So rise over run, how much over and how much over. So how much up? 1, 2, 3, 4, 5. And over 1, 2, 3, 4. So my rise over run, I got 5/4. Okay. So if I write that equation, I've got y equals 5/4, x plus 0, which is y equals 5/4. So y equals 5/4, x goes there. Okay. Now I got to decide where this thing is going from. All right. So the idea is the x values. So it starts here at 0, 1, 2, 3, 4. So it goes from 0 to 4. So low number, high number, x is in the middle, and then always less than signs when you have a and here. Okay, the idea is the graph looks like this, 0 to 4, solid dots shaded in between. That's an and. So low number, high number, x in the middle, always less than signs, which is an and then these are solid dots, so they're equal to. So equal to. So the first graph is f of x equals 5/4 x, and that's between 0 and 4, and it's inclusive, so we have the equal to signs. Okay. The last one, we have a nice straight line. Okay. And we should know from the library functions, this is a y equals line. Okay. So I take a look, I count 1, 2, 3, 4, 5. This is a y equals -5 line, so I'm going down 5. So y equals, or in this case, f of x equals -5. Okay. Now it's not graphed throughout the whole thing. It's graphed from this x value to this x value, from left to right. Okay. So I count. This is 0, -1, -2, -3, -4, -5. So this is graphed. So if I think about it on a number line, here's -5. That's a solid dot, and going across to 0. So low number, high number, x is in the middle, always less than signs. And then if it's solid dot, like this one, it gets an equal to. This one's an open dot, so it's not equal to. Okay? So final answer for my piecewise function, here's my two pieces over these two intervals. Okay? Ladies and gentlemen, that is the end of chapter 2.4. If you have any questions, I'll be able to take them the next time I see you. You guys have a great day. See you later.